Hi, everyone. Today we're going to talk about average rate of change, uh, better known as a slope. So you've calculated average rates of change in the past in your algebra classes. So what's going to happen is with this information and methods that we've learned of calculating limits that we did 2 sections ago, and then a little bit of information on how to calculate slope, we're going to put those two things together in the next section and come up with this idea of a derivative. Okay, so it's all going to come together, just a little patience, and we will get there. Okay, so just as a reminder, slope tells you how a line is slanting, whether it's going up or down, and how steep it is. And you'll remember just from algebra that you find the slope by taking the difference of the y values over the difference of the x values. So basically you need 2 points in order to calculate a slope. Okay, and that's exactly what we're going to do. The only difference here today is instead of using that good old-fashioned formula, I'm going to stick with the fancier formula. I'm going to use the function notation version. It's the same formula, y minus y. It's just I'm using function notation, right? F of x2 is just the y value for x2. And f of x1 is just the y value at x1. So it'll pay off to get used to this fancier formula for what comes next. Okay, so let's just practice using that formula on this first example. So we're going to find the average rate of change. And again, in your mind, you're going to think slope of this function from -1 to 3. So visually, let me give you a little visual here. So if you were to graph this function x squared plus 5x, if we were to look at a picture, and again, not to scale, but let's just say it looks something like this. Again, something like that. And then on that graph, you have a point at x equals -1, maybe some point here. Let's call that at x is -1. And at x is 3, you have another point. So maybe x is 3 is over here. Okay, of course, I'm just giving you a what if. And so you're going to find the slope between those 2 points, between the point when x is -1 to the point where x is 3. So we're finding the slope of this line, which is called a secant line. So what I'm going to have to do in order to get this slope is to, get the ordered pairs. I'm going to have to get the y value that goes with my x value here. And I'll have to get the y value that goes with this x value here. Okay, and then I run it in my slope formula, right? So that's where I'm headed to. So, okay, to get these y values, let's use our formula. Maybe I'll label these ordered pairs, this x and this y. It doesn't matter which way I label them, but maybe I'll call the -1. Let's call that my x1 is -1 and my x2 is 3. So let's get the y values that go with those. So let's find f of the x1. Let's find f of -1. And let's find f of the x2. Let's find f of 3. How do we find those? We plug these x values into the function, right? So f of -1 is just take -1 and plug it in the function. So -1 squared and 5 times -1. So -1 squared is 1 minus 5. What do we get? -4. All right, so that's -4. So there's our y value that goes with our x value of -1. F of 3, just plug 3 in the function. 3 squared and 5 times 3. So it's at 9 plus 15. I'm going to go with 24. 9, 15, yeah, 24. Oh, gosh. Okay, so I have my x's, I have my y's. Let's just plug it into our formula. So again, I'm using the fancy version of the formula. So the average rate of change, I'm going to abbreviate, is going to be f of x2. I'll just write the formula. F of x2 minus f of x1 over x2 minus x1. So let me plug in my values. So those would be f of x2 is 24 minus f of x1, -4 over x2, which is 3, minus x1, which is -1. Plug it in there, work it out. So that gives me a 28 on the top, divided by a 4 on the bottom, which reduces to 7. So 7 is the slope of the red line that I drew over here. It has a rise of 7 and a run of 1. And you can see that looks, relatively accurate for my inaccurate drawing anyhow. So this is our first average rate of change. Again, it's just a slope. When we finally put it in an application, it'll make more sense. Okay. All right, so let's do it again one more time. Find the average rate of change of this function, negative 2x squared minus 7x plus 3 on this interval. So they give me the x values in a little different form here. They say from x is 1 to x is 4. So keep this in mind that they're saying, hey, the x value is 1 to the x value of 4. Okay, so just giving interval notation. So again, let's pull a formula out. So I'm going to do this. I'm going to find f of 4 minus f of 1. Divide that by 4 minus 1. That's how I find this average rate of change. Okay, and again, how do I find f of 4? I plug 4 into the function. So maybe I'll just do that over here at the side here. So f of 4, right? Let's plug my 4 into that function. So negative 2, put in 4 squared, 7 times 4 plus 3. Use a calculator. Let's speed it up, right? Get practice at that calculator. So f of 4, negative 57. Let's do f of 1 because I also need that. Again, plug 1 into the function and see what you get. Again, use calculator if you like, or do it in your head, whichever way. And what I'll get, let's see, negative 2 minus 7 is negative 9 plus 6. Oh, I'm sorry, plus 3 is negative 6. All right, so those are my y values that go with those x values. And now I plugged in my formula over here. Basically, y minus y over x minus x. So I'm going to have a negative 57 minus a negative 6 divided by 3, right? Because 4 minus 1, which is 3. And so a little work there, that's going to be negative 51 divided by 3. And so I get a negative slope, negative 17. Again, I'm going kind of fast, but you can pause the video, work it on your calculator yourself. So this would be the slope. So if you looked at the graph and you saw where x is 1 was at and where x is 4 was at, you would know between 1 and 4, the graph must be actually going down, right? Because negative 17 is telling you that graph is decreasing, right? Okay, now we have another version of this, but a little fancier. We're going to find the expression for the average rate of change, meaning we're not going to get a number for an answer, but an expression, because our x values are involving h. So instead of numbers to plug in, we're going to be plugging in things with h's. So it says, get the average rate of change of this function. And again, remember when they give this interval, they're saying that the x1 is 3 and the x2 is 3 plus h. Okay. So to do that, I need to get my y values that go with these x values. So I will need to find f of 3, again, by plugging 3 in the function. I will also have to find the f of 3 plus h. That's the little bit trickier one because I'll need to plug 3 plus h into that function. Okay. All right, so let's do this and then we'll just use our slope formula again. So if you plug 3 in the function, that's pretty straightforward. 3 squared plus 8 times 3. All right, we got that. 3 squared is 9. 9 plus 24, 23. If I did that right. Oh, 9 plus 24, 33. All right, so there's the y value that goes with the x value of 3. Now, the next one, a little more complicated. We have to plug 3 plus h into the function. So I plug in 3 plus h squared, and then 8 times 3 plus h. And remember, we're getting an expression. We're not going to get a number here. So I am going to FOIL here on the 3 plus h and then distribute my 8 to 3 plus h. So when you FOIL, I'm just going to write it out so I don't do anything illegal here. 3 plus h times 3 plus h, and here I'm going to distribute, get 24 plus 8h. Okay, so do your FOIL, add your like terms together, and then we will have our f of 3 plus h. Okay, so here goes FOIL. 3 times 3 is 9. Outside, I get 3h. Inside, I get another 3h. Last, h times h squared plus 24 plus 8h. And again, the order doesn't matter. Put it in whatever order, but let's put some like terms together, like the 9 and the 24 can go together. We can add these h terms together. So let's get that cleaned up a little bit. So I'll have an h squared. I have, let's see, 6 plus 8, 14h, and 9 plus 24. There's that 33 again. So this is our f of 3 plus h. All right, a little more complicated than the last one, but now let's go and plug all this in our formula. So remember, our slope formula or our average rate of change formula is going to be this: f of 3 plus h minus f of 3 divided by 3 plus h minus 3. Okay, so again, that formula is just the same formula, f of x2 minus f of x1 over x2 minus x1. I'm just using the average rate of change formula. Okay, so let's plug all this stuff in. Again, a little messier. So here goes. For f of 3 plus h, what we got there was h squared plus 14h plus 33 minus f of 3, which is 33, all divided by 3 plus h minus 3. Okay, now we have some stuff that's going to cancel. On the bottom, the 3's cancel. On the top, the 33's cancel. So let's see what we have left for our average rate of change. See, average rate of change will be h squared plus 14h on top divided by a single h on the bottom. Now let's go one more step and reduce. We can reduce fractions by canceling a common factor. So I'm going to factor the numerator. Let's factor an h out because both terms have a common factor of h. This would be the safest way to cancel so that you're not doing anything illegal. Cancel my common factors of h, and I now have the expression for the average rate of change, and that is just h plus 14. Okay, so that was a little different. Instead of just all numbers, we threw some letters in there as well. Okay, so again, pause where you need to, back up, listen to it again, whatever helps. So this right here is our final answer for our average rate of change expression. All right, let's look at more of an application here in this example 4. So they show us a graph that represents, a business sort of application. It represents a sale of goods of a company from the year 2000 to the year 2008. So the horizontal axis represents our years, and the vertical axis here is the sale in thousands of dollars. So you can see, that this business was very much fluctuating. It went up in sales and then back down in sales. So, there's definitely some change happening there. So what we're going to do is come up with an average rate of change. And so the first one says, find the average rate of change from x is 1. So let's mark where x is 1 at on the graph, about right here. Right there, be 1. To x is 4. 1, 2, 3, 4 here. So x is 4 be about right here at the peak. And so we're going to find the average rate of change, which again, if you visualize that, we're basically getting the slope of this, what they call a secant line. So I just want to get the slope of that line. So from x is 1 to x is 4, I want to get that. Now, let's see, do they give us, they don't give us the equation of that function. Okay. Which means, you know, our answers might vary a little bit because we're going to have to estimate these ordered pairs here. And again, we'll just do the best we can. So if we maybe zoom in a little bit here and try to estimate what these ordered pairs are. So here, when x is 1, I need to look and see, well, gosh, what is that y value? I know this is 20 and then 30 and then 40, but if you look at it, it's a little bit above 30. So again, that would be kind of up to you to decide about what that is. So if we kind of estimate what that ordered pair is at 1, again, I'm going to pick a little bit bigger than 30. And again, it can vary. So maybe I don't know, let's see here. How about 132? Maybe you say 31. Yeah, it's okay. Our answers are going to be close. They might be a little off. This point up here, when x is 4, yeah, to me, that looks like it's kind of right at 50. So I'm going to call that the point 450. So again, when you're not given the function, you may have to estimate. So now we're just going to get the slope. So this one is more of a straightforward, just plug it in and get the slope for you. So our answers could vary a little bit. But in this case, we're going to do our normal y2 minus y1 over x2 minus x1. And then the only difference there being we're going to interpret our answer. Okay, so let's plug in it. And again, it doesn't matter which point you call x1 and y1. So maybe I'll call this guy the x1, y1, call this guy x2, y2. It wouldn't matter if you had them reversed, you'll get the same answer. All right, so if I do it in that order, I'm going to have a 50 minus a 32 over 4 minus 1. And so if you subtract 50 minus 32, what are 18? And divided by 4 minus 1, 3, we get a value of 6. Now, let's label this. The y values, right? These y values here represent the sales in thousands of dollars. Okay, so this is sales in thousands. So this would be thousands of dollars. So this represents dollars, you know, times 1,000. And the x values here, those x values are the years. So this would be dollars times 1,000 per year. So let's actually multiply by 1,000. And let's just call this, since we're going to interpret it, let's say this is $6,000 per year. And what is that telling me? Well, it's telling me from the year 2001, right? Because remember, this x-axis represents years after 2000. So it's telling me from the year 2001 to 2004, on average, the sales were increasing 6,000 a year. I have to say on average, because this is an average rate of change. So let me write down my interpretation here. So I'm going to say that from, you know, the year 2001 to 2004, the sales were, now how do I know they're increasing? Because I have a positive slope and I can see it on the picture too. So I want to use the word increasing. We're increasing, I'm going to say on average, $6,000 per year. That is what this average rate of change is telling me. So you can see this could be very helpful for a business. Now, it is only an average rate of change. That doesn't mean exactly every year it went up 6,000. It means if you averaged all the years out, that's what would happen. Okay. All right, so it would be good for you to pause and find part B, the average rate of change from 4 to 7, and I'll pop the answer in here so that you can check it. Again, our answers could vary a little bit depending on, the Y values you choose, but we'll get something around the same answer, okay? Okay, I popped in the answer to part B so you can check your work there. So again, if you go from 4, I called that the 0.450 to 7, and I kind of estimated that 732. Yours could be slightly different. You end up getting a negative, which makes sense because from those years, things are going down. And so the way you would express that interpretation would be like this. From 2004 to 2007, sales are decreased on average 6,000 a year. Okay, so keywords decrease or decreasing and average, because this is an average rate of change. Okay, because we're going to do something soon called an instant rate of change. So it's important we use the word average here because it's different than what's called an instant rate of change, right? Okay, one last problem then. So let's look at number 5. Number 5, we have this revenue function in dollars from the sale of X sunglasses. Find this expression here and interpret the meaning. Okay, well, I can see that formula there, that's an average rate of change formula, right? It's got the Y value at 4 minus the Y value at 0 over 4 minus 0. So that's getting me a slope. So I know I'll be getting a slope. That'll help me interpret. So let's take a minute and let's get these values here. So finding R of 4 is just plugging 4 into the function. So negative 0.01, plug 4 in and square it, and 100 times 4. And then find R of 0, which certainly will be a lot easier with 0 plugging in here. All right. And then we can plug in our formula. So R of 0, yeah, it's 0. R of 4, use your calculator, type that in. Let's see, did I get a value for that? I believe I did. And I came up with a 399.84. Now let's see what the Y values represent. So according to the problem, R of X is the revenue in dollars. Okay, so these Y values here represent dollars, right? So this would be dollars, $0 here, from the sale of X sunglasses. So X are the number of sunglasses. So our answer is going to be something in dollars per sunglasses. Okay, so let's run it through the formula. All right, here it goes. Let's do that. R of 4 minus R of 0 over 4 minus 0. So we have this 399.84 minus 0 over 4. And remember, we said the units are going to be dollars here, and on the bottom, sunglasses. Dollars per sunglass. All right, so let's see here. If I reduce, let's divide this on our calculator. So we're going to get this many dollars, about $99.96 per sunglasses. Okay, now what is that? So I think this is a revenue function, right? So this is giving us the average revenue change. So 0 to 4 means when you sell from 0 to 4 sunglasses. Okay, so let's see if I can put this in words. So how about this? When selling, let's put it this way, the first 4 sunglasses. That sounds better than saying from 0 to 4. When you sell the first 4 sunglasses, the revenue, because that's what this is going to be increasing because it's positive on average. Okay, so this is good news if you're the one selling the sunglasses. Really fast. This is a big number for the slope. So the revenue is increasing because it's positive. An average of this number here, $99.96 per sunglasses sold, right? I'll say sold. We have to assume you have to sell them to make the revenue. Okay, so this would be my interpretation. When you sell those first 4 sunglasses, on average, $99 per sunglasses is how much revenue you're going to be getting. That's how fast it's increasing in those first 4 pairs that you sell. My guess is it's going to start decreasing after that, but these must be expensive sunglasses. Okay, so this is average rate of change, also known as a slope. And keep this practice in mind. We're going to tie it into limits in the next section and come up with what's called a derivative. Okay, hope this has been helpful, and I'll see you in the next video.